Hi friends, welcome to Machine Learning Journey. This is lecture 7 of our ML series of beginner level. And in this lecture, we will understand about what is machine learning. So mainly we will discuss about what is machine learning, how we train the model, what is a model, model input, output, and difference between algorithm and model. So these are the words which I have used in the previous lecture about fitting a data into a right algorithm and it creates a model. So what is difference between algorithm and model? And then we will understand what happens during training. So we will start with one example. For example, you have one data set. You have one data set. Okay. Okay. Just a second. Let's say you have one data set. You have hours studied by student and marks he got. So let's say he studied for 2 hours and he got 40 marks. When he studied for 4 hours, sorry, he got 60 marks. And when he studied for 6 hours, he got 80 marks. Now you have this data. Now I'm asking you one question. What will be marks if he study for 5 hours? How will you just answer these questions? So what you will do is you will try to understand some pattern between input is 2 and your prediction you want to predict is marks, which is 40. So the first pair is 2 to 40, second pair is 4 to 60, 6 to 80. So how we'll try to answer, or how we'll try to approach the problem. So let's say first thing is in the machine learning also, and it is always a assumption and experimentation. Okay, first you assume something and then you experiment it and you try to prove it. So first is, let's say you this problem is a linear problem. So let's say you form a linear equation problem y equals to mx plus c. So let's say y output is you have input output pair, x and y pair you already have. For 2 it is 40, for 4 it is 60, for 6 it is 80. So let's say you have 40, you want to know m, you have a 2 which is x plus c. Again more equation, one more equation you can form is m for plus c, and then you will figure out what will be the value of m and c, and if you solve this equation, it will be like y equals to 10x plus 20. When you x equals to 2, 2 into 10, 20 plus 20, 40. X equals to 4, 4 into 10, 40 plus 20, 60. 6 into 10, 60 plus 80. So it is satisfying our data. Now you have one general equation. Now if someone asks you what will be the uh, marks obtained if x is, or hours is 5, then you will just put in this equation 10 into 5 plus 20 equals to 70 marks the student will get, and you're done. What you did exactly, you had a data, you want to know the prediction or you want to know the output of some unseen data or something, some input which output is not given. So from the given data, you try to first assume that, let's say it is a linear equation. And let's say it is a linear equation, then you did some experimentation of this, trying to solve using this data. You're trying to solve this equation and trying to figure out the correct value of m and c. I'm repeating, correct value of m and c. Then you come up with the final equation that y equals to 10x plus c, or 10x plus 20 will be the final equation. So here the assumption is correct because your general data is showing correct answer. For any input x, you can get the output y with this equation. Now you first assume and then you experiment it, or you use the data, existing data, and try to figure out the variables, value of the variables. So this is all about This is what machine learning is. Here the variable count is two. M and C, you try to figure out two variable model is. It is a two variable linear model. Now imagine the GPT models or chat GPT, they are the billions of parameter model. So they have billions of values and they are connected with some equations, or it is a mathematical representation also of a 2 billion, let's say, complex algorithm. So this is what we try to figure out. We assume number of variables first, and then we try to figure out the best value of that variable and best combination of that variable. Two things are there. First, you need to figure out the values of that variable. Let's say you assume that there are 10 variables I will need, because 10 variables are there because 10 input features are there, let's say. So for each input feature, there is some weight it will assign. Now you also need to figure out whether it will be linear or non-linear. That also we will discuss in the further lecture. But now, as of now, you understand first you assume the algorithm, then your algorithm try to figure out the value of weights you assume, then the weights you finally got, and you are confident that this is a generic weights which can perform better on unseen data, and that equation itself is known as model. The algorithm which is used to get that value is a like a recipe for cooking. Let's say you have recipe, you have a cooking and you make cake. So cake is a model, cooking is a action you took, the way you approach the problem, and the recipe is algorithm. So you know if you want to make a tea, you will have an algorithm steps. Step by step, you have to follow this. The way you implement the cooking, it took the action. That is a learning, and the final output you got is a model. Okay, it's a just example. So if we see a definition, machine learning model is a mathematical representation that learns pattern from data and makes prediction on unseen data or new data. So model is a pattern finder. Okay. So simple analogy is like you practice the question of some subject, then in exam you get some variation of that question or in that domain, and you answer that. For example, you are preparing for physics exam, so you practice the physics questions. Now in the exam you don't get exactly what question you practice, but there is some variations, so that exact uh, question is unknown to you, but since you have already practiced so much question, you know the patterns. So this is in this ML version also, it is same. You have a training data, you train the model, and then you make prediction. Now uh, now we will discuss about what happens during training. During training, what happens is like what I did during training, I tried to figure out mn value of m and c, right, with the different values which are already given, with the data already given. I'm trying to figure out what will be the best value of mnc. So this is what during training happens. During training, you might have heard about epochs. So for each epoch or for each trial or each experiment, you try to figure out the values of the variable you assume, how it will fit into your data. The best fit, you take that model and you just say that for unseen data, it will also uh, predict well, since you have tested on the test data. We have already discussed on the previous lecture about training data and test data. So this is all about what exactly machine learning is. So you understood the difference between model and algorithm. You understood how assumptions are made. So this is all about this lecture. We will discuss in the further lecture about linear regression. Finally, about how exactly the linear regression works and why it is known as linear, not something else, and what kind of algorithm it is, and what kind of data can fit into it, and why we need some more complex algorithm. See, the answer is like for complex algorithm because the real world representation of things are complex, not linear. For example, you want to know the weather prediction of tomorrow's weather prediction, you need inputs. So input also, let's say you have uh, past data inputs, you have all temperature, humidity, the climatic condition, location, you already have. Now, will it be a linear that humidity plus temperature plus whatever the value comes, it is a percentage of prediction of weather tomorrow. It is not like that. It doesn't work like that because the complex data has some complex patterns. To figure out that complex patterns, your algorithm should also be a complex enough and it should fit into the data so that it can catch the patterns. Always keep in your mind, assuming the algorithm, you don't need to memorize the data of a training data. You need to make it generic so that it can perform better in unseen data. Because during the deployment in the production or in the real world scenario, you will get the data which is not seen in the history. No problem, no matters how easy the problem is or how complex the problem is. In the real world, the data which comes in the future is always almost unseen. So this is all about this lecture. Thanks a lot, and we'll meet in next lecture with some more interesting beginner level concepts.